Graph the following function using at least 3 points of accuracy. State the domain and range, the equation of the axis of symmetry, all x and y intercepts, and the maximum or minimum value. A quadratic function is one in which the input variable, typically x, has a degree of 2. As an example, f of x equals 2x squared plus 3x minus 5. The graph of a quadratic function is in the shape of a parabola. The example that's given above is in the form called standard form. Standard form is f of x equals ax squared plus bx plus c. Note that a here cannot be equal to 0, as then it would not be a quadratic function. For a quadratic in vertex form, which is f of x equals a times x minus h all squared plus k, h comma k give the coordinates of the vertex of the parabola. This is the point at which the parabola changes direction. This will always correspond to either the minimum or the maximum point. The sign of A indicates the direction of opening. If A is greater than 0, then the parabola opens upwards. If A is less than 0, then it opens downwards. The magnitude of A indicates how steep the parabola is. For example, if A is equal to 3, this corresponds to a vertical stretch by a factor of 3 relative to the basic y equals x squared parabola. The axis of symmetry for a quadratic equation will always be a vertical line. X equals h. Note that it's going to be x equals the x coordinate of the vertex. Unless specified otherwise, the domain will always be all real numbers. The range, however, will depend on the direction of opening. If it opens upwards, because a is greater than 0, the range will be y greater than or equal to k, all real numbers. Note that this is y greater than or equal to the y-coordinate of the vertex. If it opens downwards, because a is less than 0, then the range will be y is less than or equal to k, and all real numbers. For this question, f of x equals negative 2 times x plus 1 squared plus 8. In this case, h comma k is negative 1 comma 8. This means that our vertex is at negative 1 comma 8. Note that here we have an a value of negative 2. This means it opens downwards, and there is a vertical stretch factor of 2 relative to the y equals x squared graph. This means that as we move left and right 1 from the vertex, instead of moving up or down 1, we move up or down 2. In this case, we'll move down 2. This gives a point at 0, 6 and at negative 2, 6. Similarly, as we move right 2 or left 2, instead of moving down 4, we would move down 8. This gives a point at 1, 0 and negative 3, 0. We now actually have 5 points of accuracy. We can now draw the parabola. Always remember to put arrows on both ends of the parabola. For the domain, in this case, we have not been specified a restricted domain. Therefore, our domain is going to be XER x is an element of the set of real numbers. For the range, because our vertex is a maximum point, meaning that it opens downwards, we would say for the range, y must be less than or equal to 8, 8 being the y-coordinate of the vertex. For the axis of symmetry, recall that the axis of symmetry will always be x equals the x-coordinate of the vertex. In this case, the x-coordinate of the vertex is -1, giving us our axis of symmetry of x equals -1. For the x-intercepts, we can look straight from the graph. The x-intercepts correspond to y values of 0. This happens at -3 and 1. The y-intercept corresponds to the point where x equals 0. This corresponds to 6. And finally, because this parabola is opening downwards, it has a maximum value. That maximum value is 8.